All right, we're going to go through and read the sig fig rules and talk about them a little bit. So, Brandon, why don't you go ahead and read rule number 1 for me?
All non-zero digits are significant.
Every digit that is not dealing with a 0 is significant. So where we're going to find the problems with this, obviously, is going to be with the 0 numbers. Non-zero digits are significant. Emma, rule 2. If it's a 0 between non-zero digits, they are significant. Number 3, Brianna. All zeros to the left of the first non-zero digit are not significant. I call those front end zeros. So if you look, let's really look at the second one down there. 0.00179. I find the first non-zero digit, which is the 1. Everything to the left of that, those zeros to the left of that 1 is not significant. Those are front-end placeholders. So that would be 3 significant digits. Rule number 4. Go ahead, George. So, if it's to the right of the last non-zero digit and to the right of a decimal point, that 0 is significant. So if I look, once again, let's look at the middle one, 60.00. The 6 is the last non-digit number. That decimal point in there tells me that every 0 to the right of that decimal point is significant also. So that is 4 significant figures. Maddie, read rule number 5. Okay, so if we look at this one, 420 right here, 420 right here, that 0 is not significant. There's no decimal point there. So that is a placeholder. So that is 2 sig figs. 650 with the decimal. That decimal says, yes, that 0 is significant. So that is 3 sig figs. If you look at 8,000, the third one, those are back-end zeros with no decimal. Since there is no decimal, that is not significant zeros. That is 1 sig fig, the 8. Now, one thing I have to tell you about too is the bar on the top. Let's say I have 8,000 as so, and I need to have 2 significant figures. Well, obviously, if I put a decimal right here, is that still 8,000? No. Is it 2 sig figs? No, that would be 4 sig figs. What I need to do is I need to put a bar over that. So that bar on the top of that says that that 0 is significant. All right, so that would be 2 sig figs if I would put a bar there. So I could put a bar over any one of those, and they would be significant then. That's not what I want to do. I want to get that off. Heck with it. I don't care. I'm only going to be doing this. Okay. where are we at now? We are at Allison, right? Read rule number 6 for me, Allison. Okay, when we're dealing with scientific notation, all of the digits in front of the times 10 are significant. So, let's look at this bottom one here. 9.010 times 10 to the 4th. Every one of those digits would be significant. Now what we're going to do is we're going to do a little bit of practice on these sig figs. So, as we go through and look, you might want to write down some of these, take some of these examples down in your notes. The very first one, and we're going to go through these quickly if you don't need to. If you don't need to write everything down or any of these down, that's perfectly okay. But let's look at this. Which answer contains 3 significant figures? As I look at that, where are we at? Lewis, how many sig figs are on number 1 there? There are 4 sig figs on number 1. So number 1 is not a correct answer. How many sig figs right here on number 2? How many sig figs here on number 2, Cindy? There are 3 sig figs there, so that would be a correct answer. What about right here? Kayla? Is there a decimal after that 0? Huh? Any non-digit, so we at least have 3. So we have to decide if that 0 is significant or is that a placeholder. It is a placeholder. I would agree with that. So if I would put a decimal point behind it, it would make it significant. No decimal point, so that one is 3 sig figs also. Look at B here, Carly. What do you think? All the zeros are significant in which one of these or more of these? Are all the zeros significant in number 1? Yes, no, maybe. Okay, let me go back. Read to me. Look at rule number 3, Carly. Okay, what does rule number 3 say? Read it to me. Okay, so that would make all of these zeros not significant right here, correct? So, are all those zeros significant? No. What about this one right here, Justin? Yes, all of those are because of that decimal point right there. What about this one right here, Michaela? Before you answer, read number 6. Read number 6 out loud for me. What does it say? Okay, so all digits in front of the times 10 are significant, right? Okay, so all of those zeros are significant. Okay? Round that number to 3 sig figs. Okay? To 3 sig figs. Is number 1 correct? Mason? No, it is not. 534,675 is definitely not the same as 535. Is number 2 correct, Fletcher? Yes, to 3 sig figs, I needed to put in 3 placeholders. That is a correct one. What about number 3, McKenna? Yes, all I've done is put that into scientific notation. Any number in front of the times 10 is a significant figure. Read this question for me, Sydney.
And which set or sets both numbers contain the same number of significant figures?
Does number 1 contain the same number of sig figs? No, it does not. Okay, the first one is 3, the second one is 4. Austin, is number 2 the same number of sig figs? No, it is not. The first one is 4, the second one is 1. Alexa, is number 3 the same amount of sig figs? Yes, it is. The 1 and the 5 are both significant, and all those zeros are placeholders. Okay, here we are, Chloe. Okay, state the number of significant figures in each of the following. How many right there? 2 sig figs, excellent. Callie, how many right here? 4 sig figs, excellent. Okay, that one once again. Okay, once again, dealing with those zeros, that is, where's the one that is after? To the right of the decimal point, number 4. Okay, number 4, that is rule number 4. Brandon, we're back over to you, bud. What about this one? How many sig figs there? 1. All those zeros are placeholders. Good. Emma. 3. 3. Yes, that is just the rule we talked about. Okay? The right of the decimal point are significant. Where are we at there? Brianna, how many there? This is a tough one. Excellent. 3 of them. Okay? This one is sandwiched in between 2 non-zero numbers. So these 3 are definitely significant. Now I look and say, okay, is there any decimal point in there? Absolutely not. That's a comma. No decimals, so these are placeholders. There are 3 significant digits there. Nice job. All right, adding and subtracting. This is the back of that page. Adding and subtracting the back of the page. Where are we at? George, you got off easy. Read the rule right there.
Decimal points alive. The least number of decimal places among the measurements determines the number allowed in the answer.
Okay, it says decimal points. When we align up the decimal points, the one with the fewest places, if there's not a decimal point, it's the smallest number. What I mean by that is, let's look right here. I have decimal places here. 25.2, that is to the 10th place, 1 place after the decimal. Here is 1.34, that is 2 places after the decimal. Which one of those is the larger number? 1 place pass or 2 place? Obviously, the 10th place is the larger number. So what I'm going to do is I'm going to round right here. So I'm going to have 26 point something because that 10th place is the largest one. As I look at that, does the 4 cause the 5 to round up? No, it does not. So my correct answer here is going to be 26.5. Okay? 1 decimal place passed. Now, what I was talking about before is, let's say that we don't have a decimal at all. Let's say we have 15 and we have 200 here. We don't have a decimal place at all, right? But what is our smallest of these numbers? Okay? I look here. Here is a sig fig. Here is a sig fig. Which one is the farthest one? It's going to be this 5. So I'm going to round right there. So this would be 215. All right, so if there's not a decimal point, unless there's zeros there, now, let's look at this right here, okay? Let's look at this right here. I don't even have to add these up, okay? I don't even have to add these up. I look here, and I say, okay, here is 10th, 100th. So the sig fig right there is to the 100th. Here is the 10th. Here is the 10th. So I'm going to round this wherever to the 10th. This is rounded to the 100th, so I know that can't be right. This is rounded to the 10th. That could be it. This is rounded to the ones place. That can't be it. So I didn't even need to add these up. I know that's got to be the right answer based on the sig figs. Look this one. Just because it's subtraction doesn't change anything. Which one of these answers are the correct one? Or is the correct one? Who at? Where are we up? Where are we up at? Maddie, which one of these are correct? Number 3, because it's at the 10th place, correct? Now, go ahead, Allison, and read the multiplication one. No, on your rules. Count the number of... So multiplication and division is different. We count the number of sig figs in each one that we're doing. So I look here. 2.19 is how many sig figs? 2.19 is how many sig figs? It's 3. How many sig figs are 4.2? It's 2. Which one is lower, 3 or 2? 2. So my answer has to have 2 sig figs. Does that have 2 sig figs? No. Does that? Yes. Does that? No. So that's got to be the right answer. Didn't even have to do the math. Division's the same as multiplication. How many sig figs right here? How many sig figs? There's 4. How many sig figs here? 1. Those zeros are placeholders. They're front end. So this number has to have one significant figure. So that number 3 has to be the correct answer. Number C here. Number C. Letter C here. Okay? Letter C here. 3 sig figs. 2 sig figs. 3 sig figs. 2 sig figs. How much must my answer have? 2 sig figs. Is this 2 sig figs? Is this 2 sig figs? Yes. Is this 2 sig figs? Yes. I better do the math here. Okay, I better do the math here. Somebody plug those in on their calculator, and let's do the math and see which one is correct. I've got 2 possible answers that could be correct. Which one is it? 2 or is it 3? I hear 3. I hear people say 2. Did you multiply both of those before you divided? What'd you get? Number 2? Please excuse my dear Aunt Sally. What comes before? Multiplication or division? Multiplication. So I multiply the top, I multiply the bottom, then I divide the top number by the bottom number. Okay? If you don't understand, please excuse my dear Aunt Sally. We'll talk about that later. Now, here's the deal about this whole sig fig bit. All right? The idea behind significant figures is, as we talked before, there's uncertainty in each measurement. So as I am looking at this, I see I have a ruler that has centimeters. I have a blue line. I know this is 2, this is 3. So my big markings, my major markings are 1, and my minor markings in between are 1, 2, 3, 4, 5. It looks like 0.1. Okay? So this is 2. This is 2.5, 2.6, 2.7. I know it's 2.7. Is it 2.8? Is it 2.8? Is it to that dot right there? No, it's in the middle, correct? So that is where we have our estimation. So, what would you call this number right here? Where are we at, Lewis? Are we at Lewis? What would you call that number there? 2.7. That's right on that dot? Is it right on that dot? You can't see? Too far away? It looks to me like that's in between the two dots. Okay? So I would actually call this 2.75. I know the first one's a 2. I know the second one's a 0.7. This third one is my unknown digit, and it's somewhere in the middle, so I'm going to call it 2.5. You could have called it probably 2.6. You could have called it, 2.75. You could have called it 2.74. You could even called it 2.76. It's ballpark. It is in a certain area. Now let's look at this one right here. Same thing. Same thing. I got that little green line. I got to get a little better angle at it. This, I know this is 9, right? I know it's 9.5. I know it's 9.6. Is it 9.7? Not yet. This looks to me like it's not even halfway in between. Okay? So, could I call it 9.6 and be correct? Could I call this 9.6 and be correct? No. I know it's 9.6. Okay? I know it's 9.6. I know it's not 9.7. Could I call this 9.62 and be correct? Absolutely. That 2 I estimated. Could I call this 9.3 and be correct? I just said 9.62 was correct. Could I call it 9.63 and be correct? Yeah. Okay, yeah. Just because one person estimates that to be a 0.02 and that to be at the 0.03 mark, it does not matter. That can happen. So basically, if you were to say, what are significant figures dependent on? They are dependent on the device that you are using to measure. There is an estimated value on every measurement, no matter what you're using. Even if you use this digital scale right here, it's going to estimate that final place. Okay, that final digit will be an estimation. It's just it does it internally for you. Okay, so the significant figures depend on the different types of measurements and the whatever you're using to make those particular measurements.